Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today I will show you a tutorial by using Multisym in order to complete the simulation of medical instrumentation for laboratory 1. So first and foremost, this simulation was conducted in order to complete tasks in laboratory 1 of medical instrumentation subject. This laboratory 1 was divided into two parts, which is simulation and circuit construction, which was carried practically during laboratory season. So this is the objective of this laboratory. Next is for simulation software, we are using this component. First is Multisym version 10 and above, so we can use the LabVIEW instrument, operational amplifier OP07CP, resistor, variable resistor or potentiometer, optic sensor, which is photodiode, phototransistor, optocoupler and red LED, multimeter and oscilloscope. So let's see the figure that we want to construct by using Multisym. Figure 1 shows the circuit's construction, which we need to simulate it. So let's proceed. I already constructed the circuit. Make sure the connection are true and try to run it. If there are any error, we need to debug or troubleshoot the circuit. So there are zero error. First and foremost, we need to record and investigate the characteristic response. So click here at LabVIEW instrument, select signal analyzer and put it here. Connect to the pin 6 of OP07. Try to run it and click here. So this will show the characteristic response of the circuit. Pause. Next, we need to measure the current and voltage and also power at certain point. For this circuit, for first task is we need to measure the current and voltage and power at point C and E. Instead of using multimeter, we can use probe, which are easier. Put it here, point E, point C. Okay. For this task, we need to vary the value of resistor from 10 to 0 ohm. So let's try for 10 ohm. Let's see the voltage and current at both points. Try to run it. So for 10 ohm, which the voltage is 992 millivolt and 0 ampere, both are the same at the same point. Try to change it to 9 ohm. Run it. Okay, here the voltage and the current will be changed to 1.97 volt and 336 milliampere. So let's try for 8 ohm. Run it. The voltage show 1.9798 volt and 378 milliampere. There are slightly change of the value, but the value stays same at point E and C. So let's try for 0 ohm. Run it. The voltage show 5 volt at both point and 1.11 kilo ampere. Quite high current. So these are the option 1, which we use photodiode. We need to use other option of optic sensor as shown below. Next, we try to change from photodiode to optocoupler, but the connection of the circuit and the component remain the same. So this is the for circuit for option 2, which use optocoupler. As usual, click the view instrument and select signal analyzer, put it here to measure the characteristic response and run it. There are no error for this circuit. Okay, these are the characteristic response of the circuit. Next, as usual, we need to measure the current and voltage and power at point C and E. Use the same probe, place it here and here. Let's try for 10 ohm first. .97 volt and 303 milliampere. The same at the for this both point. The value of the voltage and current are the same. Let's try for. We can change the value from 10 to 0, which we need to tabulate and record for each resistance when we change it. So I already tried from 10 to 0 and I already seen the change in it. So let's try for 5 ohm. Okay, it changed to 2 volt and 600 milliampere. Let's try to 1 ohm. 2.09 volt, 2.91 ampere. So these are the current and the voltage for both points E and C. We can change the resistor. We need to change the resistor from 10 to 0 ohm. So that's for option 2, which use optocoupler. Let's try for option 3, which we need to use phototransistor. As usual, remain the same, the component. Here I change to potentiometer or variable resistor, which are easier to change the value of resistor. So place first and foremost, we need to click here, level instrument and signal analyzer. As usual, we need to measure the characteristic response of the circuit. So here the graph. So next, we need to measure the voltage and current at the same point C and E. Place the probe so we can read the reading. Try to run it. So for 10 ohm, the voltage is 1.97 volt at both point and 303 milliampere. So try to change to 3 ohm. Okay, the voltage changed to 2.03 volt and 990 milliampere. This shows the voltage and current at both points. As we need to measure also the value of power, so we need to use formula P equal to VI, which means power is equal to voltage times current. For example, we can calculate it for 3 ohm of resistance. We need to find the power. We just multiply the value of voltage and current, and we can get the value of power. Okay, next, back to option 1. After we measure the voltage, current and power at point C and E, okay, this figure shows the option 1 photodiode, option 2 optocoupler, and option 3 phototransistor. Next, we need to variate the value of R2. Let's see R2 here, from 50k ohm to 1 mega for each option, which means photodiode, phototransistor and optocoupler. We need to use all those options of optic sensor. Increase each change by 10%. We need to measure and record the result of each option and tabulate form during the each incremental for both point D and F. Point D and F. So place the probe here, point D, and here, point F. Let's see the change. So we need to measure from the value of R2. We need to change from 50k to 1 mega by 10%. So let's try starting 50k of the resistance of R2. Okay, point D and point F. Try to run the simulation. Okay, this probe shows the voltage at point D is 293 nanovolt and 686 picoampere. Meanwhile, at point F shows 34.6 microvolt and negative 686 picoampere. So let's try for other value of R2. We need to change it from 50k to 1 mega. Try to 145k ohm. Let's see the change. 293 nano, 686 picoampere. Meanwhile, the value at point F 99.8 microvolt and negative 686 picoampere. Let's try with another value of R2. 240k ohm. Run it. The value at this point remain the same. Meanwhile, the value at this point will change slightly. The value of volt, the current remain the same for 240k ohm. Let's try with bigger value, 810k. Try to run it. As I mentioned before, the value at point D remain the same. Meanwhile, the value at point F we change to 556 microvolt. The current remain the same. Let's try for 1 mega ohm. Run it. The value remain the same at point D. At point F, the volt change to 686 microvolt. The current remain the same. This is because the voltage from the voltage have voltage drop after run through the 1 mega ohm, so the voltage will change. Meanwhile, the current remain the same. Next, let's try for option 2. delete this probe, place it at point D and F. As usual, from 50k to 1 mega. Let's try 5 to 5k. Run the simulation. Okay, the value of the voltage at point D is 168 nanovolt and the current is 686 picoampere. Meanwhile at point F, 44.4 milli and the current is negative 84.6 nanoampere. Okay, let's try with another value. Let's say 335k. Run. Okay, the value of the voltage will change to 217 nanovolt. The current remain the same at point D. At point F, the voltage changed to 36.6 millivolt and the current changed to negative 109 nanoampere. Okay, let's try for 1 mega. Okay, the voltage, the current at point D, the voltage and the current at point F. They are slightly changed in both value because we changed the values of R2 ranging from 50k to 1 mega. Let's try for option 3. As usual, delete this probe. We don't need this. This we change to back to 10 ohm. And this 10%. Select resistance, we change to 50k. Place the probe, point D, point F. Run it. Okay, at point D, the voltage is for 50k ohm is 293 nanovolt. Meanwhile, the current is negative 686 picoampere. At point F, 3.72 microvolt and 686 picoampere. Okay, let's try with another value. 905k. Run it. The value at point D remain the same. The value at point F will change. See, 62.4 microvolt. The current remain the same, 686 picoampere. Okay, as I said before, we need to change the value of resistance from 50k to 1 mega. Let's try for lastly for 1 mega. Run it again. The value here at point D remain the same. Meanwhile, the point at point F, 68.9 microvolt and 686 picoampere. Okay, we need to measure the power also, as mentioned here. Voltage power. So in order to measure the power, as usual, use formula P equal to VI. We multiply the voltage with the current, the voltage with the current, so we get the power at certain point for both point at certain resistance, which ranging from 50k to 1 mega. Okay, next is for circuits construction. Circuits construction was carried out practically and laboratory session which included in our report. So that's conclude our tutorial. Thank you so very much